Okay, in algebra, there's certain things that come up a lot, such as distribution, factoring, solving quadratics, and just the shortcut things. We develop formulas based on observations. These patterns, or algebraic identities, are some of those basic formulas that can be used to shortcut and simplify things. A lot of the times they're used for factoring, but they can also be used for distribution. In this example, we're going to apply them for distribution to this expression where we have 2x squared plus y to the third in parentheses, and we're squaring that expression. So if we look at it, that would be starting with the factored side. Unfortunately, I put it too close to the bottom. So it'd be starting with this side here. This is the factored side. Okay, and more specifically, because it is a set of parentheses squared, we're going to be looking at the middle formula. So in order to actually use this, we need to be able to identify what a and b are, and when you're starting with the factored side, identifying a and b are usually pretty easy. The first expression a, second expression is b. So when we go to apply to the formula, we just have to replace a with a and b with b. So we have a squared. Now you'll also see this plus minus sign. That's another thing that throws people off. But you can also notice that the two signs, the plus minus here and plus minus here, match. Now, plus minus in this situation is used differently from how it is in the quadratic formula. The quadratic formula means there's two variations. However, in these formulas, it is just a way of representing whether the sign is the same or whether the sign is the opposite. For example, if you look in the third formula, you'll see that there's a plus minus here and a minus over plus. That indicates that the two signs are opposite. So in our case, when we're looking at this particular problem, because they are the same, they are both plus minus, we will keep the same sign here. So we have a plus, so we're going to have plus 2ab plus b squared, and we will fill out this pattern now that we have a and b, and we know which sign we have to choose. So a is 2x squared, so we're going to do 2x squared squared plus 2ab, so 2 times a, which is 2x squared, and b is y to the third, and then plus b squared, so plus y cubed squared. Now going through to simplify this expression, when we raise a product to a power, we want to raise each individual factor to that power. So we're going to raise 2 to the second and get 4. And then when we do x squared to the second power, we multiply the exponents and get x to the fourth. For the middle expression, we're going to multiply our coefficients. So the 2 here times 2 gives us another 4. And then x squared times y cubed, we can't really do anything with that, so x squared y cubed. And the last term, all that's in the parentheses is y to the third, so we're just going to do the power to the power, multiplying the exponents to give us y to the sixth. And there we have it. Okay. In the second example, we're going to be factoring the expression 9m to the fourth minus 25n to the sixth. Now, as I do this, a lot of times we do use those algebraic identities to help us factor. And when you are factoring, you're going to be looking at this side of the formula without the parentheses. That's the side you're going to focus on when you try to identify which pattern or which identity it follows. You should, before you do that though, check to see if there's a common monomial in both terms, and then try to figure out which pattern it follows. So there is no, in this case, common monomial between both terms. 9 and 25 share no common factors, and there's none of the same variable in both terms. Since this expression has two terms, I know if it's a pattern, it's going to be either the first one or the third one. And the only difference between the two really is the exponents, whether it's squared or cubed. So we just have to figure out a way to identify whether it's squared or cubed, and then go from there. In this case, though, I know 9 is a perfect square, so I would assume it is the a squared minus b squared pattern, which will factor into a plus b and a minus b. In order to figure out what a and b are, though, I'm going to rewrite it here. We need to write it as each term as something squared. So that's what I'll do now. So just think to yourself, what do you square to get 9? Well, 3 squared is 9. You can always just take the square root. And then for m to the fourth, well, what do you raise to the second power to get m to the fourth? Remembering that the property, when you do a power to the power, which is going to be the situation that's going on here, you multiply the exponents. Oops, writing the wrong thing. So what times 2 would give us 4? Well, m squared to the second power would give us 4 because we do 2 times 2. For the second expression, or the second term, what do we square to get 25? Well, we square 5. And then for the variable, we're going to look at what times 2 gives us that exponent. So what times 2 gives us 6? That's 3. 3 times 2 is 6. So now that we've rewritten it, we can clearly see what a and b are. A is 3m squared, and b is the 5n to the third. Now we just have to apply it in the formula. So we'll have 3m squared plus b, which is 5n to the third, and then a minus b, so 3m squared minus 5n to the third. And there we have it. Okay, in this video we're going to be factoring this expression x to the third minus 216. Normally when you factor, the first thing you want to do is to check to see if there's common monomial. There isn't anything that goes into both terms in this case. So now we're going to check the patterns to see if it's a pattern. We would check this side to see if it follows any of these. And because it has 2 terms, it will either be the first one or the third one. And based on the exponents alone, with it being x to the third, exactly x to the third, I would say if it's any of the patterns, it would be that third one there, which is a little bit cut off. But it should follow that third pattern if it's indeed a pattern. So just going through with what we have, I'm going to rewrite the formula up here just with the correct signs. So a to the third. Now, the plus minus sign in this formula just indicates whether you're going to keep the sign the same or change it. So since our original sign is the minus sign, we're going to be following the bottom sign when there's a double sign. So it's going to be a cubed minus b cubed is the initial thing. Then on the other side, the factors would be a, keep the same sign because the plus minus sign stays the same. So we'll keep our minus sign, b. And then in the second set of parentheses, if I move down just slightly, you'll see that's a squared. But you'll notice that the plus minus sign changes to a minus plus sign. That's going to indicate whatever sign we originally have, it's going to flip to the opposite. So our original problem has a minus sign, so we're going to flip it to the plus sign. And then then we have the AB, the last sign is always a plus. So that's the variation of this formula that we're going to be looking at. Now that we know what the signs, we just have to figure out what a and b are. So just like I did with the squared one, I'm going to write it like this, just to help. And what do I cube this time to get x to the third for that first term? That seems a little pointless, but we cube x to get x to the third. And for 216, if we take the cube root of 216 into a calculator, if you don't know it off the top of your head, you will get 6. So we raise 6 to the third power to get 216. Now that we know what a and B are, A and B just being the stuff in the little parentheses here, we can apply them to the factors side. So it's A minus B, so x minus 6. And then A squared, so x squared, plus A times B, so x times 6. And then plus B squared, so 6 squared. I'm going to put parentheses around that x as well. And because there is parentheses and stuff, I'm going to want to just simplify this factor a little bit here. So my x minus 6 won't change, but the x squared will be x squared. X times 6 is usually written as 6x, and then 6 squared is 36. And that would be the factor form of this expression. Okay, in this last example, we're going to factor the expression 8x to the third minus 27y to the ninth. So with this, again, we would want to check to see if there's a common monomial in both terms. There's not a common monomial, nothing goes into both 8 and 27, and there's not the same variable in both terms. So no common monomial. Once again, because it has two terms, or because we're factoring, we're going to focus on this side of these identities to see which of these it follows, if it follows any of them. And based on the fact that 8 is a perfect cube, I would assume it would follow the third one. So I'm going to go ahead and write out the signs for this before we actually get to it. So we're going to have a cubed. Now the plus minus sign is based on the original sign that we're starting with. We're starting with a minus sign. So a cubed minus b cubed. Now on the other side, the plus minus sign will just indicate whether it changes or stays the same. So we'll have a plus minus sign stays the same there. So minus b. And then in the second set of parentheses, we'll have a squared. You'll notice that it flips. So we're going to change that sign. So to plus now. AB. And then the part that's cut off is the plus b squared. So plus b squared. So that's the variation of the formula we're going to use. And now we just need to figure out what a and b are to actually do this. So remember that a is what you cube to get the first term. So what do we cube to get each of these expressions? So what do you cube to get 8? Well, 2 to the third power is 8. You can always use the cube root on a calculator. And what do you cube to get x to the third? Well, we cube or we raise x to the third power to get x to the third. For the second term, what do you cube to get 27? Well, we cube 3 to get 27. And what do you cube to get y to the ninth? Remember the way the variables work is to what power do we raise y to? So that y, or that exponent times 3 will give us y to the ninth. Because when you raise a power to a power, you multiply the exponents. Well, in this case, 3 times 3 is 9, so we know it's going to be y to the third raised to the third. With that, we have the pieces that we need, and we can fill in the formula. So we have a minus b, a being the thing in the first set of parentheses I wrote, and b being the second term. So a is 2x minus b, which is 3y cubed. Then in the second set of parentheses here, for the second factor, we're going to have a, which is 2x squared, plus ab, so plus 2x times 3y cubed, and then plus b squared, which is 3y cubed squared. And then we just have to simplify that second factor a little bit so we can make it look a little bit nicer. So 2x minus 3y cubed is my first factor. It's not changing. The second factor, we're going to raise both bases here to that power. So 2 squared is 4 and x squared is x squared. The second term, 2x times 3y cubed, is going to be 6xy cubed. Then for the third term. 3 squared would be 9, and y to the third raised to the second is y to the 6. And there we have our final answer. And you can just skip straight to this. It just helps to write this first line here out as you're first doing it. So